Hey there, everybody. Thank you for making it out to another ISSessions session. We got another jam-packed event scheduled for you guys. Making its debut with the new exec team, the news Roundup is coming back. Speaking of segments that are coming back, we're going to be having the return of Rick's Repo Rundown right after that. And then after a break, Jackson, our event manager, he'll be delivering tonight's feature segment, and it's going to be all about SOCs. It is a very common co-op position, so any first or second years in chat may want to pay attention to that one. Before we get started, though, I would like to draw your attention to the presenting form up at the top of our Discord server. At ISSessions, we're always looking for potential speakers, not just for our main segments, but also the 30-minute middle segments, as well as even our news roundups / discussions. You don't have to be an exec to participate in those. And hopefully this will kind of break down the wall and get some more people involved. Even if you're unsure about which segment you want to do specifically, or even about what you want to present on, feel free to fill it out and we can discuss the details later on. But without further ado, let's get started with the news.
Hey guys, this first story comes from Russia, from Ars Technica, involving a group of hackers from Russia, in which attacks against Lithuania, the country, had started on June 20th and had continued. Over 130 government websites and businesses were victim to DDoS attacks. The Russian hacktivist group called Killnet declared war on 10 nations, targeting other countries like Germany, Italy, Romania, Norway, as mentioned, Lithuania, the US, as well as other countries. It's been noted by a security firm that they are not working together with Russia, but are in support of it. In April, the Five Eyes, or UK USA, warned against the damage that this group and others could potentially cause. Other hacking groups like ZachNet have also contributed to furthering Russia's interests through cyber attacks and are even being promoted by state media. In response, in Ukraine, a volunteer IT group had conducted cyber counterattacks against Russian targets. One recent example of an attack is one of Putin's speeches having been delayed by an hour after an attack. And after this attack was caused, he went on a 73-minute rant about how much he dislikes the West. What we're seeing here is another dimension of war conducted through cyber operations. How far can these attacks be pushed without causing serious escalation?
This next story comes from Bleeping Computer, and it is about a vulnerability in certain Honda car models. Two independent researchers have found that several 2012 to 2022 Honda car models have an insecure rolling code mechanism, allowing someone to unlock these cars or start their engines without its key fob. So how does the keyless entry system in Honda cars work? When you press the key fob to unlock the car or start its engine, the key fob sends a radio frequency signal to the receiver in the car. This signal contains commands and a set of rolling codes. These are security codes that are continuously generated and used for authentication. Rolling codes are produced by a pseudo-random number generator to make sure that unique codes are generated every time the key fob is pressed. And there is a counter that increases each time a new code is generated. What the researchers found is that they could force the counter in certain Honda vehicles to resynchronize by sending the car lock and unlock commands in a sequence. This causes the car to accept codes from a previous session, which should have been invalidated. Then software-defined radio equipment could be used to capture a sequence of rolling codes and replay them at a later time to unlock the car or start its engine. The researchers filed a report to Honda about the vulnerability and posted a write-up and videos demonstrating it. It is also listed in NIST National Vulnerability Database, and others have since been able to replicate it. However, in a statement to Vice, Honda maintains that the report is not credible and that the allegations are unfounded.
Hey guys, this next news comes from. This next news segment is about Microsoft Word and a vulnerability there. So this vulnerability was dubbed Felina, and it allows remote code execution when a user downloads a malicious Word document. The vulnerability is exploited specifically through Microsoft's diagnostics tool, and after an attacker convinces their victim to open the document, the attacker can execute code, gain remote access, move laterally in the system, and escalate user privileges. The vulnerability was discovered through a document submitted from Belarus, which used the external link in Word to load HTML and execute PowerShell code using the Microsoft's diagnostics tool. The vulnerability appears to be exploitable on all versions of Office 365, and since a zero-day was announced, Microsoft have reported active exploitation of this vulnerability in the wild.
Hi, everyone. So Apple recently announced a very helpful feature for its users, a feature called Lockdown Mode. It's part of the new software updates coming in the fall of this year for most Apple devices that can download it. It's an extreme but optional protection for a very small number of users who face, quote, grave targeted threats to their digital security. It's designed to protect against sophisticated digital threats, such as those from the NSO group responsible for the Pegasus project and other similar private companies who have been sanctioned by the state. Just for some context, the Pegasus project was software developed that was already used in retaliation to successfully hack some smartphones belonging to journalists, government officials, human rights activists, and anyone in general who have openly criticized their governments. Features will extremely limit attacks by blocking vulnerable aspects of Apple devices, such as messages, by blocking things like attachments and links, Apple services like FaceTime, web browsing compilations, wired connections, and configuration profiles like VPNs. A new bug bounty program that basically doubles the reward up to $2 million by Apple. It's considered basically the highest maximum bounty payout in the industry right now, or potentially. Apple also established a $10 million grant to help any organizations who are willing to combat these threats with their developers.
Hi there, this is Jackson, and for my article, I'll be doing hackers impersonating cybersecurity companies. So hackers are impersonating well-known cybersecurity companies in callback phishing emails to gain initial access to corporate networks. Phishing campaigns embed links to landing pages that steal login credentials or emails that include malicious attachments to install malware. Quote unquote callback phishing campaigns are the new kids on the block, in which hackers impersonate well-known companies requesting you call a number to resolve a problem, cancel a subscription renewal, or discuss another issue. The threat actors use social engineering to convince users to install remote access software on their devices, providing initial access to corporate networks. This access is then used to compromise the entire Windows domain. One example of this is the impersonating of CrowdStrike. CrowdStrike is a cybersecurity firm which hackers warn the recipients that a malicious network intruder has compromised their workstations and that an in-depth security audit is required. If the victim is called, the hacker will guide the employee through installing remote administration tools that allows the threat actors to gain complete control over the workstation. Threat actors can also remotely install additional tools that allow them to spread laterally through the network, steal corporate data, and potentially deploy ransomware to encrypt devices. Next, please.
Okay, so my article is about a new technique that has been up and coming called basically ransomware without ransom without ransomware. So a gang called Lunamoth has been making use of this technique. So this attack relies on phishing. So this gang conducted a large-scale phishing campaign that actually used fake subscription emails from companies such as Duolingo, Zoho, or Masterclass. What probably could have been seen if they were checking is that these messages were not sent from a valid Duolingo, Zoho, or Masterclass domain. They were just sent from a Gmail account. So you'd hope that people would see that Duolingo probably wouldn't use a Gmail account. They'd have their own email. But I guess that's how they get you. So the email contains a PDF, which urges the customer to call a phone number if there are any issues. And then this PDF usually either is a malicious attachment, or they get them to do something and install something when they call the number. It seems to vary. And then through that process, they then deploy tools that allow them to gain both persistence and the ability to exfiltrate whichever data they want from the system. So basically, it lets them take whatever's on your computer, and then if you try to get rid of them, they'll come back again and again and again. And then they, it's not ransomware in the sense that they lock down your files, but they say, I have your data. If you don't pay me this much amount of money in Bitcoin, I will put it on the internet. Which, of course, if it's just my family photos, that's probably don't mind if that's on the internet. Like, obviously, don't want it there, but if it's something business critical or very personal, such as like bank information, that's stuff that you don't want on the internet for anyone to use. It could cause you some trouble. And this game doesn't really have any specific targets or like certain profile of a target that they attack. They kind of just set out a wide net, and wherever they get some catches, they take it and run with it.
All right, thank you, Jackson. Really interesting story there. Sounds like our fun with phishing segment from the last session could have been some useful information for those targets.
Yeah, we should send it to them.
Yeah, just another reason to come to our sessions. Won't be victim to ransomless ransomware. Another story here, our last one. This one coming from Cyber News. An adware campaign that has been targeting search engine requests has been identified and exposed by Palo Alto. The adware, dubbed Promoter, it doubles as both adware as well as an info stealer. And the way it works is by using a malicious browser extension, it's going to install a listener, and this listener, it's going to intercept any outgoing request. So it's going to look at that intercepted request, and if it's to a search engine like Google or Bing, etc., it'll send those details to the attacker's command and control server. And basically what it's doing is it's targeting its target's thoughts and interests based on their search queries. And this thing's been kicking around for a while, over half a year of activity. And the attackers behind it, they've just been improving the code, making it more efficient, making it more effective. And now there's even variants of it, 3 of which targeting Windows, 1 of which targeting Mac users. So I guess Linux users stay winning. And they're probably just going to keep on working on it and keep on improving it. So I don't know, I guess be aware. So thank you for that. We're running a bit ahead of schedule. Rick's Repo Rundown will be coming up soon. I guess going back on the news segment, if this seems like something you might be interested in, once again, feel free to fill out our presenter form, and you'll be able to participate. It'll look good when you're applying for co-ops, which maybe you'll be applying for a SOC job, which you'll be experts on by the end of tonight, thanks to Jackson. But in the meantime, I guess we'll take a short break. And when we're back, we'll be joined by Nick, aka Rick, for Rick's Repo Rundown. Thank you, everybody. Welcome back from our impromptu break. We're joined now by Nick, aka Rick, for Rick's Repo Rundown. So feel free to take it away.
Cool. Awesome. Thank you. Hi, everyone. I hope you can hear me okay. Please let me know if you can't, because I just had like an audio issue right before I joined. So could someone maybe just in the stream questions make sure I'm coming through okay?
Yeah, we can hear you.
Amazing. Awesome. Volume's okay and all that. Cool. All right. Hi. It's been a while. Thanks for asking me back. So I'm going to do the quick rundown thing, and then I have a couple of words I want to say at the end. Hopefully you can see my screen. I decided to do it a little bit differently this time. Often in the past, I've like made a PowerPoint and we just go through that, but I was just gonna click through the actual repo this time, because a couple people have asked me in the past, like, hey, how do you actually do these? So maybe that will show you. I wanted to use this tool, or talk about this tool that a lot of people like. It's a command line tool. It's called the fuck. And basically, it's a tool that if you like mistype a Linux command, you would just type fuck after, and it suggests what it thinks you meant by that command. And if it got it right, you just hit enter, and it will run the command. So there's like a little animated GIF you should be able to see on the screen. I will dump the repo name in the chat. It's pretty straightforward. There it is. So yeah, it's a cool tool, right? It does, like, the way it kind of tries to figure out what you meant is interesting. You can also have it kind of, you can hit up or down and it will try different commands, things like that that it thought you meant. But basically, it's gonna like kind of queue up the command here that it thinks you meant, and you hit enter, and it's just gonna run. It's as though you just typed the command on the command line. It doesn't immediately run it for you. There is a setting where you can tell it to do that, where you don't even have to hit enter. There's also this like experimental instant mode that I didn't really dig into too much. But yeah, anyways, that's this kind of neat utility. So where do you start? Something like this. Because when I first opened up this repo, I was like, oh, okay, my normal thing that I do is to go into the folder that's usually the name of the project and look for main, right? Because most programs have names, especially Python. There's no main here, right? So my like default is, oh no, when I can't find a primary entry point to a program, where do I go? Usually the install or setup script, because that's going to tell you, you know, where this thing deploys to, and usually like what it's going to kind of configure as the primary command to execute this thing. So there's a whole lot of content in here. Normally, if you're just poking through, right, anything with a dot in front of it, you can probably ignore. Right, and a bunch of this other stuff like the documentation, like the README, and the GIFs obviously aren't interesting. There's like install.sh, there's setup.py, and there's some like other just stuff in here. The one that we want to look at is setup.py. Install.sh will get you there too, but if we click on setup.py, so here is a bunch of this we can kind of ignore. There's a lot of standard like Python boilerplate for the building of a setup.py file. It's pretty standardized. The part that we're interested in is towards the bottom. Here's just it checking requirements for you know, packages and stuff that be installed. Here, right at the very bottom, like the last thing that this thing talks about is entry points. So this is where is main in this program when someone runs it. Also, we get the author name in here. So Vladimir, thank you for this cool tool. Apparently, it was according to the documentation, it was based off of a random tweet from Liamasaur, I think, that just, you know, talked about an alias they had that did something similar to this. It just reran the last command from their history file. Anyway, so here it's saying the main is in project name.entrypoints.main:main. So there, in the entry points folder, there should be a main.py, and in there a function called main that we want to run when someone runs this. So if we go back to the actual repo, so we go to the project folder, lots of stuff in here, and then so there should be entry points, the one that we go to. And then in entry points, here's main. I click on main, and we're just gonna kind of like trace it through until we get a rough idea of how this thing works, because I think this is neat. So here's the actual main function. A whole bunch of imports at the top that we don't necessarily care about yet. All the dots are like relative imports though, from the other like folders inside this project, whereas there's a couple of like system level imports like the OS tool and the sys tool. OS usually for getting like path information, and sys for getting command line arguments. And so someone types a Linux command, they mess up, then they type fuck and hit enter. What happens then? So we call main. It creates some kind of parser object. Presumably this is to take any command line arguments, because you can pass an argument to this thing, but usually you don't need to. And it'll, maybe depending on that, it'll print out the help instructions. If you ask it for a version, right, it'll do some debug versioning info for you. But the part that we're interested in is if they just don't provide any kind of arg, or if it's like they start to enter in a bit of a previous command. This is the function or the part of the if else block that we probably want to drop into. So what it's saying is if you are aware of this command already, or there's a TF history in the OS environment variable, then we will go to, we will call this fix command function, passing in the arguments that we know about. Otherwise, it can pull from like the recent like shell commands as well, but this is usually the one that's gonna get run most of the time, or it's gonna like print out aliases that you might have. So this is probably where we're gonna go next. Okay, so we're gonna click on, I love this new feature of GitHub where I can click on fix command, and it'll take me to that function definition, wherever that is. So elsewhere in this project, in entry points fix command.py, this is where this function gets defined. So let's find out where we go after we mistype our command. So I click on fix command, it takes me into this this file. Here's the definition. Fix is previous command used when the fuck is called without arguments, which is what you're going to be doing most of the time. It's going to do some initialization stuff that we don't really care about. If there's logging, cool, it will, for debug purposes, will start to process that. But the first major thing is raw command underscore get underscore raw underscore command with the known args. This is where it's going to try to basically look up what you just did. Because for it to figure out what you were trying to do, it needs to know what command you just typed. So if we look at get raw command for a second, I'm just going to open that in a separate tab so I don't lose my place here. Here's get raw command. So it'll do most of the time this stuff right here, because we're usually not passing args. So first off, it tries to check your history. What it's doing here is it's checking some kind of command history file, either like your history file or one that gets set up automatically when you install this program. And then this part of Python is a little bit of like file opening / substring magic. Basically go to the history and split on /n means basically take all of the lines out of history and separate them into like an array or a list where the separator is a new line, because there should be one command per line. So it's going to split up all your history commands. And then this is going to grab the most recent one. This is basically telling Python, go to the end of the list and grab the last element in the list. So we're basically grabbing the last command out of history. Then it's going to round up all your aliases that your shell uses. And again, this thing supports a number of shells, so there would be some install work that teaches it how to parse this or how to parse your aliases. But if we just open that up, it's just in a utils here. It'll just look up your alias file and open it. And then it will also get all the executables, because when you type a command in a Linux shell, right, it's going to do one of two things. Either the command you typed is a binary, a program, and it will check your path environment variable for all those different folders, right? And if the program is found in any of those folders, then it will run the program. If it's not in any of those, or sometimes prior to those, it will check your alias file to see if you have an alias configured that has the name of the command you just typed, and it will run whatever the alias is. So we have to round up all those things, because those are all the potential options of things that could get executed when you type a command. So we read in all the aliases, then forget all the executables. Again, there's a little bit of debug stuff here, but the important stuff is right here. So we have this output or this variable called bins. We know it's going to be a list. If you're not too familiar with Python, a list is just an array. It's going to be a list because it starts and ends with these square brackets. So inside here, all this is like one big function that's going to result in spitting out an array or a list called a list comprehension. So what we do is we check the path environment variable, and we split it up into a bunch of little paths, right? And then we basically search all of those little paths. We create a big list out of all the stuff in those paths, and then we iterate through it, and we look to see if that program name is in this big list of paths. And if it's not, then we haven't found it. We do a similar thing with aliases. Again, we just look through the aliases and grab all those, and we're going to return all the program names and all the aliases back to where we were, which is in this fixed command function. All of that gets bundled up. Where am I here? Into this generic thing that is executables. So for each of the commands that we previously ran in our history, we're going to run this thing called sequence matcher, which is like a Python statistics library tool. And it's going to look through all the aliases and the commands, and it's going to find out basically which, how do I explain this? So it's comparing these like two lists of commands, and when there's a certain set of difference between them, because a lot of it should be similar, when there's a certain set of difference, like greater than 50%, I think it's going to dump that into this list here. And we're basically checking to see, is the thing that we ran more likely to be in one or the other? I think it's mostly like a speed up thing, like which one do we want to check first? I didn't dig too far into this part, but essentially this is all grabbing your aliases and your executables and searching, starting to search through that, and we end up returning this thing called command, which is what the program more or less thinks is the command based on your history and your aliases, or the potential commands you have access to in your shell that you might have been trying to run. So once we have what we think might be the raw command that you ran, we can look down into this try catch block. Either you didn't run a command and you just typed fuck and there was like no history, or here we'll try to figure out some more details about that command. So this types.command from raw command. So we're going to take what we think is the command you ran. We're going to create a new type, which is like a object, if you want to think about it in Python-y terms or in Java-ish terms, called a command from this thing that you just ran. The command type that they define in this project is like a wrapper around commands. I'll show you kind of what that means. So we create this like little command object that has a bunch of methods, functions that we can call, and we create that from the like base thing that we found, whether it be an alias or the name of a program or something like that. And like a regular class, it's going to have a bunch of these properties that we can call. One that's going to be of interest to us much later. Where is it? Oh, I think there's one that's like a subclass of this. Anyways, later on, there will be like a run method that's part of this that will help us with running the command. But anyways, so we create some kind of command object, and at the basis of it is either the program name that you wanted to run or the alias or something like that. Okay, so from there, command then goes into get corrected commands, and then we end up with a list of corrected commands. So we can see what that does. We can open that up on the end here. So get corrected commands returns generator with sorted and unique corrected commands. A generator in Python is just going to be like a list of things that you can iterate over, like a list that we can like loop over and compare. So the list of corrected commands is going to be what we get when we do corrected for rule in get rules. If rule is match on the command, then we kind of add that to our list and we're going to return that. So the way that this program ends up working is we look at the command we think you ran, we compare it against a bunch of the rules that this program configures when it's installed or that you can add yourself. And this is where we start looking for things that are like similar to what you typed. And the rules will define what ends up actually executing. when you eventually tell this thing, oh, hey, you found the right command. So this get rules thing just opens up some path and grabs all the rules out of it. I'll show you what a rule looks like in a sec. And it's just going to then start looping through all those rules, comparing all those rules to maybe the command that you typed. So let's have a look and see what some of the rules look like. I'll do it in this one. Don't need this tab anymore. Here we go, rules. So, I mean, we have to pretend we typed some kind of a command. Like, say we meant to type apt-get install something, and we typoed on apt-get, or we typoed on install, or something along those lines. So this is the collection, or this is the rule that's meant to match against a mistype of apt-get install. So here. If we end up matching on this, so it's gonna search the output of the previous command and look for like not found or not installed. That might be some of the error output you get if you mistyped apt-get. So it's gonna kind of look for that as the way to determine if this was a match. Because if you mistype apt-get install, again, one of these two things is probably going to be the error message that you received. So in addition to looking at the command, it looks at like, what was the most recent output there. And if it ends up finding that, eventually sometime in the future, this thing's going to suggest that, hey, maybe this is what we meant to type instead based on this rule. Maybe we meant to type sudo apt-get install and then some package name. But we haven't quite gotten there yet. It's the match part that it's running right now. So we will look for these types of output, and maybe that's what we meant. If that match did happen, we get it in corrected commands, and then it goes into this UI element where the user has to select which of the commands is the right one to execute. Where the first one, like you can hit enter and it'll run it. So basically, all that happens here, this is just like printing a status message out to the command line, not this part. This is kind of what ends up getting printed, though. It's going to print out like the primary command, the first one that it thinks first, like the one it thinks was the most accurate one. And here, it'll make sense if I actually show you the output. Because since it's just text-based, there's no real picture. So it's kind of hard to explain this part. But the output, right? So this is the stage we're at. We're printing this part from this UI element. This is going to print out this selector here, and this is going to print out this. Based on all the rules that matched, it will start to print these from the list of all the rules that matched. So the first one that it thinks you meant to type it's going to be the one that has the best match or matched first. It's now waiting for you to enter a command. It doesn't really show it, so to speak, but it's understood that once it prints this to the screen, here's your little prompt. It's saying, hey, hit enter if this was the right command, hit up or down to cycle through the list of commands we thought it could have been, or hit Control-C to just cancel this altogether. So that's where in this UI, it's sitting here waiting for your keystroke. We dig into this, it's just a thing that's just reading the current active keystroke. And depending on which key you give it, if you hit enter, this is where it's going to basically print out the action to run. Abort is Control-C, so it'll just bomb out and it won't suggest anything. And then there's the hitting the up and down arrows, and it will basically run the selector thing again to show you the next command. So when you do that, it will, when you pick one, it returns this selected value to you. So let's just say it shows me the right command. I hit enter. What happens then? It's going to spit that out as selected command. And then if that was the command that I selected, then selected command .run the command that it thought we ran. So if we go to that .run method in types, where are we? How did I close that? Okay. I'll open up command again. Here we go. So that command that we kind of instantiated or created runs the command for a rule from the past command. So where is the, here, sys.standardout.write self.getScript. So basically it looks into the rule itself, and it's just going to write that out to the command line so that you can hit enter and run the command that you want. That's kind of it. How do we know what it's running? Well, it's self.getScript, and this is based on what we extracted from the rule, and I had that one rule open. Did I close it? There it is. So that's where it's going to pull this for you, and it's going to basically issue this or write this out to the command line, and you just got to hit enter, and that's how it knows what thing you want to run. That was a bit of a quick mess of just typing through and running through the real basics of this. Obviously, there's a lot of like stuff I skipped over, like lots of error checking and logging and stuff. But what it ultimately boils down to was this fixed command is usually what's going to get run when you just hit enter with no arguments. It's going to pull. Where am I? It's going to pull your list of all of your aliases and all the commands that could have potentially run based on what your path environment variable was. It's going to look at those and then your most recent element from your history, try to figure out if it can find a match based on a whole bunch of these rules. If it finds a match or if it finds multiple matches, it's going to return them in this collection of corrected commands, at which point it will give you that little UI element, which just waits for keystrokes from you. And when you find the one you want and hit enter, that's where it just dumps and runs that command for you. I thought initially when I was looking at this that it did some kind of like, I don't know, like heuristics or learning, or some like way more intelligent parsing of what you could potentially do. But no, it's really just looking through a combination of like your aliases, some of your command history, and the path environment variable and all those things, and just trying to match that against your most recent history entry, and then coming up with a suggestion, and that's it. It's actually, it's like a lot of different parts, only because the program, it's pretty mature by now. Like it's been around for quite a while, so it's been refactored a bunch. Like the code's all nice and broken out into all the different modules and pieces and stuff just to make it more maintainable. But ultimately, that's all it is. It just does a quick lookup from your history into your path and maybe aliases, suggests a thing, prints it out, and you hit enter and it runs. Like we didn't talk about like some of the constants and exceptions and some of these other things, but basically that's it. This other stuff like the shells, the specific, the system, this is all kind of based on the install and setup, where it knows how to work with like the different types of shells. So if you're like using bash or if you're using ZSH, basically just how it's going to set the environment variables that it uses to like look up your history and a bunch of things like that. This doesn't really get referenced a whole lot at runtime, I don't think. Like maybe some of it might be, but that's kind of it. So that was it. No PowerPoint this time, just me rambling about how I kind of really quickly looked at this and came up with a basic understanding of how it works. Yeah, the GitHub feature of follow the function click is my new favorite thing because you no longer have to navigate through the folders to find all the stuff. It just tells you where this function gets defined. This is the greatest thing ever for trying to get a really quick, comprehensive idea of how a piece of code works. If lots of that was confusing, my apologies. Just ask me, and I'll point you to things. Yeah, definitely, Jim. This is normally what I would have done, and like with the old repo rundowns, I just take screenshots while I do exactly what I did, and I just dump those into the PowerPoint, and then I just kind of clean up my explanation a little bit. But this is normally how I run through these. I don't. It's really easy to get lost in the rabbit hole of following like lots of function calls, like following init. What does this do? And then eventually, the more you do this, the more you realize a lot of this doesn't matter. We're just trying to follow the main like flow of control. Like, oh, okay, well, the thing we know we're doing is like trying to execute some command. So anything that says command in it's probably important. We seem to be creating an instance of some object, so that's probably going to be important. Like even the function names are very self-descriptive. Get corrected commands, select command, right? Command.run. Like just these three function names tell you probably a lot about what's going to have to happen. And I usually let that guide me, and I can dig in where I need to. That's generally how I do this. Hopefully one day if you need to read code, maybe that will help you as at least a where to get started on that kind of thing. Yeah, that was it. That's really what I wanted to talk about. So this is a cool program. If you didn't know about it before, awesome. Hopefully I got to introduce you to that, and you can now add that to your shell and enjoy the awesomeness of just having essentially like autocorrect in your terminal with a little bit of expletive, because that's funny. I guess you could change the name probably, like if you didn't want to type fuck every time, like if you wanted to type oh heck or something, you could just alias it, or you could change it if you wanted some like non-X-rated terminal stuff. Yeah, that's that. Other things. I'm gonna steal another couple minutes of your time. So those of you who know me, if some of you don't, I used to be the coordinator for the Sheridan ISS program. Hi, I'm Rick or Nick. I recently left that job that I held for about 11 years ish. I wasn't the coordinator for that whole time, but I taught for like 11 years. And it was amazing, and it was like the greatest job. I really liked what I did. It was amazing to work with everyone in here who is a student and an alumni. I especially enjoyed working with the people who took over club executive roles, because obviously just my involvement with the club, I got to know them a little bit better, and it was always awesome to see their dedication and how much work they put into running this. And I'm so glad that this will continue to grow and be a cool community, even now that I've gone on to other things. Yeah. So the program itself, I'm happy to report, is going to be in good hands. There's lots of like basically road mapping that shows like a lot of the changes that are coming in the coming years. I got a lot of that done before I left. There's just like things in motion to happen, so that's nice. I hope the program continues to turn out the best cybersecurity graduates in the country. No bias there at all. And yeah, I hope to still come and hang out at meetings and things like that. And if I can, I will still try to attend the odd pub night just to say hi. Or if these ever return to in person, I will definitely come to the odd in person meeting, because yeah, I really, really enjoy the club and what it is, and catching up with all of you. So again, thank you everyone for everything you've done over the years. You are amazing. Thanks for letting me rant at you for a couple minutes. And yeah, that's kind of it from me. I'm gonna stop sharing my screen, because otherwise we're just gonna look at details on when this program was last updated.
Thank you, Nick. And I think it goes without saying, you always have an open invite, whether you want to hang out or talk about some cool repo you found on GitHub. Thank you for that segment. We'll be moving into our scheduled break here. And then at, say, 8, Jackson will be delivering his talk on SOCs. So the CCR code is on screen. I'll send a link to the CCR form. Feel free to fill it out. I recommend it, because we're starting to run out of opportunities to get your hours up for this term. I'm not sure if Jackson really needs much of an introduction, but he is our event coordinator. Probably seen him around for quite a while now, and well, he's in his co-op term over at ISA, right, Jackson?
Yep.
I mean, it'll be on your intro slide, but
yeah. So yeah, like I said before, like Jack just introduced me, I am Jackson. I am in my co-op term right now as a SOC analyst, and I just kind of wanted to do this talk because I feel like being a SOC analyst is a very common co-op position, and like I've seen like so many people get jobs in it. But I feel like I didn't really have a great idea of what a SOC was, and like how it functioned when I was actually going into co-op. So I thought, hey, I'll do this talk and I'll talk about it in a bit more depth from my experience. Okay, so who am I? I'm currently on my co-op term after my 3rd year of the Sheridan InfoSec program. I'm currently an ISSessions executive. I was also on the content team last year. I'm the event manager this year. And personally, I enjoy playing video games, chess, and Dungeons & Dragons. And obligatory dog picture, because everybody does that. And here's just a little pun I thought of. My dog likes socks. He's a SOC analyst, and I'm a SOC analyst. Okay, never mind. So basically, I'm just gonna say about my co-op quick. So I'm a cybersecurity analyst at ISA Cybersecurity. I'm just about 3 months. I think it's like next week. 3 months. So far it's been a mix of in-person and remote work. I started off going in like all the time, except when we were doing online training, where I was at home all the time. But now that I've kind of settled more into the role, it's like I'm 2 days in the office and the rest of the time it's remote if I want to be. So like I said before, we started off with some online trainings. Those were all from the ISA cybersecurity partners, and it was about some of the different technologies we'd be using. Then we went on some practical trainings where the other co-ops and I we were with our team lead, and he would show us how to do some tickets, kind of explain the ins and outs, and then we kind of did like a trial run almost, where we worked on some alerts and kind of ran it by him what we did, just to make sure we did it right. And now, probably about after like the first month and a half, I was pretty much just doing the standard job full time. And we kind of began with some simple tickets and learned more complex ones as we went along. And yeah, so ISA Cybersecurity, I don't feel like it's a super well-known company, at least as Sheridan. It's based in Etobicoke. Their main office is in Etobicoke. It offers a variety of services such as consulting, SOC, defer, and architecture design and implementation. It's partnered with major companies such as Cisco, Trellix, Proofpoint, IBM, and Fortinet. And through those partnerships, we use a lot of their technologies. And yeah, so that's where a lot of our like the start of our training came from. And so what I've noticed about ISA so far is customer service and company culture are a huge focus. I'm going to get into this a little later, but basically we have people who are assigned to each client in the security operations center, where they like literally have meetings with the client every week. They tune rules that they want to change and basically make sure that all of their needs are being met. And yeah, I'm going to talk a little bit more about that later. And company culture is also a huge focus. I've already been to like few there's been a few parties and stuff. Like one we like the SOC team like took a bunch of TVs down in the office, went into the big boardroom. We brought a Nintendo Switch, Xbox, and a PlayStation, and after work we just played video games for a while and hung out with pizza and stuff. And then there was another one that was like the whole company that was a little fancier. I actually was invited to that one before I even started at the company. So I think that shows how they treat their employees. Like I haven't even started working yet, and I was invited. So that was really cool. So it's generally called a SOC, but CIOC is technically what it is. I'm going to get into the acronym later. So it's certified as a SOC 2 Type 2, which is good, basically. I don't want to get into that too much. And we offer 24/7 service. So at ISA, it's something called an MSSP, which is a Managed Security Service Provider, which basically means that we don't just do the internal, like ISA security. We have a bunch of clients who we do some of the security stuff for them too. So we kind of act as their SOC. First off, I've said SOC a bunch of times. I'm not talking about SOCs that you wear on your feet. So SOC, it stands for Security Operations Center. It's a team that is responsible for detecting and investigating cyber threats. And depending on the team, there may be an element of incident response as well. So it can be an in-house team or SOC as a service, which is kind of like what we have at ISA. And generally the team receives alerts that they then investigate and either close or escalate, which I'm going to get a bit more into that later. So the teams often split into different tiers. So like level 1 analyst, level 2, and level 3, where each hold specific responsibilities. And it can also be called a CIOC, which is a cybersecurity incident operations center, or an ISOC, which is Information Security Operations Center. So they basically mean the same thing. from what I've seen, you can kind of just use them interchangeably. It's just kind of the company's preference what they want to be called. SOC seems to be the most common one, though. I'm going to talk about some helpful terms quick, just to make sure everyone's kind of on the same page with these things. So when I use these acronyms, people aren't like, what does that mean? So first is SIEM, SIEM, Security Information and Event Management. It's basically a software that collects and analyzes activity from across an IT system. And then you can also create alerts to be triggered based on specific rules, and that's how the SOC kind of functions, is we get these alerts. And some examples of themes are Splunk and QRadar. QRadar is probably the one I see the most with my job, but it really depends on the company. Now, an IDS is an intrusion detection system. It's a device or application that monitors a network or system for malicious activity or that might go against a policy. And an IPS, which is intrusion prevention system, is super similar to an IDS, but it also has the ability to take a set action against what it detects to kind of respond before a person can get there. And then EDR, which is endpoint detection and response, is a system that gathers and analyzes security threat information from different endpoints with the goal of finding breaches as they happen. So you can get an alert that something is in progress, that we've seen something suspicious, and you should probably take a look. Now I'm going to talk a little bit quick about the different tiers. These definitions are kind of the standard ones, as if it was like the in-house SOC for a company. So if you were, say, at like Bell and you were the SOC there, you might have these roles more. That's just first couple that came to my head. But it's a little different at ISA because as I said, we do it for our clients. So these tiers are a little different. I'm going to talk about that as I go through. So for the standard tier 1, they're responsible for the triage of events to determine whether they are malicious or not. Responsible for escalating events if they are real, unremediated events. And so that's pretty similar for both. Basically, the tier 1 are the front line. They take a look at all of the different events. They see if it's a threat. And if it is, they send it the ladder. If not, they can kind of close it and say, it's not a threat because of this, this, and this. Tier 2 is where it branches off a little bit and gets different. So in a standard SOC, they are kind of incident response almost. So in a standard one, what the tier 1s escalate, the tier 2s will then investigate more. And they find more information and formulate a response to contain the attack. And they also help implement security measures to prevent those attacks. And it's a little different because with my company, we escalate to the client because a lot of our clients have their own security teams. So instead of escalating to the tier 2s, each tier 2 is assigned a few clients. I think it's usually like 2 or 3, who they are responsible for communicating with, talking to them about their different needs, and formulating the rules that they want to make the alerts, to get the alerts that they want. And they also work a lot with fine-tuning these rules. So if there's a bunch of false positives, they're going to change stuff up to hopefully make it so we get less of those. They want to make the rules as like accurate as possible, so you see all the true positives, but as few false positives as possible. And so tier 3 in a standard SOC works more as a threat hunter, and they do things like penetration tests or security reviews, and then they use what they find from those to recommend changes to the system or to the general security strategy. So at ISA, it's a very different role. It's basically, we only have 3 tier 3s, and they each have a very specialized role related to the SOC. So 2 of them work in automation. So we have this like useful kind of like a bot that can look through certain tickets and actually like do it for us. So if it's kind of an easier ticket, that bot might be able to kind of swoop in and take it, just so that's kind of one less that we need to worry about. And then you literally only need an analyst if it's escalated, and then they communicate with the client, because obviously the bot does not communicate with the client. And so 2 of them work on automation, but the third one is basically he is specialized in the different technologies we use for the SIEM. So any upgrades, updates, implementations, troubleshooting, he's in charge of that. Whenever we do an update, if something goes down, we call him. And he also just does general tuning and stuff like that. So I've said ticket a bunch of times, and you might be saying, what is a ticket? So it's basically a notification that some rule has been triggered. And so the way it works is we have a queue. So whenever new tickets come, they'll pop up in the queue, and an analyst can claim them, and then it's their responsibility. So normally the ticket contains a bit of basic information, such as IP addresses, source and destination, usernames, times, and other important information. It includes a severity level, which I'm going to get into a little bit later, an assignee, and a reporter. The assignee is the analyst who claimed it, who's in charge of investigating and either escalating or closing. And the reporter is basically the email that the client says that we want all of our stuff to go to. So sometimes it's a specific person, sometimes it's more of a like general email that it's like their cyber team, so everyone can see it. And yeah, so we have to set that when we escalate it. So then there's something called an SLA, which is a service level agreement. Basically, whenever a company starts off with us, they have a contracted time in which certain things happen with the ticket. So there are 3 almost time limits with that. First one is the time it takes to be assigned to someone. That is usually 15 minutes. So that's the time it basically needs to be taken from the queue and started to be investigated. It's usually 15 minutes. The second one is time to update. So that's basically your time to either close or escalate. So that really depends on the client and the ticket. For some, it's like you have like a full day to work on it. Like you have a full 24 hours to investigate it. But then others, it's like more like an hour, or like the like most urgent ones are like 25 minutes. So those are a little quicker. You also have an offense number and or a link that'll bring you to a specific offense page in the SIEM. That'll give you some more information and help you with a search, kind of figure out more. I'm going to talk a little bit more about that later. And there's also a comment section. So that is actually how we escalate our tickets. There's a comment at the bottom, and you fill it in, you press send. And then they can send another comment as a response, either saying, hey, this isn't really a threat, you can close the ticket. Or they'll say, hey, I have a question about this. Can you answer it? Sure. And you go back and forth basically until they say, you close the ticket. Yeah. So I'm going to talk a bit about severity quickly. So it's a level from 1 to 4, 1 being the highest and 4 being the lowest. And depending on those, they have a very different amount of impact, and they have a different way we escalate them. So a Sev 1 is a very high impact. So this is something like a huge outage or ransomware. The company is going to be very affected by this. Like it'll make them have to go into business continuity, basically. These are the highest things. Sev 2 are also pretty major, but kind of less than Sev 1s, but they still have a significant impact. This can include malware, credential changes, and possible signs of attack. So those are things that will hurt the company and could signify a big attack, but not necessarily going to destroy the whole company if it's left unchecked. Sev 3 are by far the most common. These are lower impact or risk, or one that can be more easily remediated. Forgot to add a third one, but I know what I was going to say. So examples include phishing, multiple logons, or like different location logons, or I was going to say data exfiltration or like some other network things like that aren't too severe. And step 4 are the super low risk events, low impact, or very easy to remediate. There are like honestly very few of those. Same with step 1s, there aren't very many. Well, you'd hope that there's not very many step 1s. But so step 4s are usually the ones that the company doesn't really care about that much. Some have like multiple, usually the companies that have a more mature security system will be able to remediate some of the step 3s more easily. So sometimes those are considered step 4s. So for example, a multiple logon one might be considered a step 4 if they have things in place to remediate. So step 1s and 2s are very different. They're the more severe ones. So we don't actually just send in a comment and hope that someone sees it. We actually call in at specific numbers. And we keep trying. For step 2s, you try a few times, like every 5 minutes, and you try different numbers. But then after, I think it's 5 times, if you don't get a response, you kind of just say, I didn't get any response. Like, it's kind of their fault if they don't see it. But then for step 1s, you keep calling them, rotating the numbers every 5 minutes until they pick up, because these are giant events. Like you need to bother them to notice it until they respond. And so these are just some of the things that we use to investigate. So an offense page, that's pretty much in the team solution. Whenever an alert is triggered, it creates a page to go along with it. Basically says the alert name, some like associated IP addresses and events. It kind of takes a bunch of related events and puts them together so you can all see them. But usually it doesn't get all the events, which I'll talk about in a minute. We also look at past tickets. So sometimes when something's a false positive or something that is like regular activity, you can look back at a past ticket and just figure it out. So if there's, let's say a process that sometimes it thinks is malware, the system, but then you like look at a past ticket and you realize, okay, this is just a standard thing they use. Then that's kind of an easy way to close or maybe know if something needs to be escalated. That way you can also see some patterns, because if something keeps getting escalated and escalated, you might want to say to like a tier 2, like, hey, this thing gets escalated a lot. Is there something wrong? Do we need to fix something? So that's super useful. And then the log searches, because as I said before, the offense page doesn't include everything. It just can't. So in the SIEM solutions, we do a log search. So basically, you search through based on something like username or source IP or device name, and you can find other events that have similar attributes from the past, however long you want. You can also sort them, have different fields. So for example, I might add on an error code so I can see what error code triggered for each alert or for each event. I might sort by event name so I can see, okay, there was 150 of these events. That's kind of bad. Or okay, there's 2. It's not really a big threat. We use a lot of trusted open source tools. I'm going to talk more about it later, but there are a lot that are very useful. We use VirusTotal a lot to check out hashes and IP addresses and similar things like that to see if they are malicious. We use a few sandbox softwares. Yes, we do review the open source tools before we use them. There's kind of a list of tools that we're allowed to use. We don't just go on the internet and get anything. We use a sandbox, App Anyrun. It's pretty good. It's basically, you can run any website or file from within this sandbox, and you can see the processes that spawn from it. So you can see if something malicious is happening. In Christian, I don't use a full account of VirusTotal, but there are some that we have accounts on. Normally, we don't really need it for VirusTotal, I find, with what we've been doing so far. at least from what I've been doing so far. And then there are a few that for some of the IP tickets that like are just lifesavers. Like there are websites that show you where an IP is in the world, and if it's a VPN or not, because it's kind of because some of these things are impossible to tell. Like you can't. It's hard to look at an IP address and say, "Yep, that's a VPN," or "Okay, yeah, that's from Germany," or "Okay, that's a Toronto IP." It's impossible to say. So these tools can tell you and make it so you don't need to just escalate to the client saying, "Hey, was this you?" We also have a knowledge base as a company. So that includes a lot of basically guides on how to do certain tickets that might be common. Step by step, tells you some things you should look for, some reasons you might escalate it or not escalate it. The knowledge base also has all of our customer information. So if you need to know who to contact or even like some of their admin accounts, because a lot of time we see alerts for like an admin changing something, we want to know, are they actually authorized or is this some kind of privilege escalation? Also, sometimes there are things you can't figure out other than customer contact. It's impossible to for us to know if someone is on a business trip and logging in from a different geolocation. So sometimes you just have to escalate it and tell them, and then they'll be like, "Oh yeah, Joe is in Florida right now. He's on vacation." We don't. I'll get to that in a minute, Abdul. Just give me a second. We don't know. We try not to escalate too much because we don't want to bug them. And some of these companies don't have huge security teams, so we don't want to spam them with kind of meaningless checks. But yeah, and then there's some internal or customer tools that are specifically set for the client. Just recently, I first used Nexpos, which from there you can look at every device that's set for them, and you can the way it's set up is there's an alert that'll say a certain type of vulnerability that they think someone's trying to execute, but you can check on this website to see if that computer is protected against that vulnerability or not. So if someone's doing like a brute force attack and it thinks it's doing a brute force attack, then you look on it and you see, okay, this has a security solution set up to protect against that. Then it's fine. Like we know that's not going to affect it because it's a trusted source. And back to Abdul's questions, how often do you catch people trying to hack your network? I'm not allowed to say specific like incidents or name the customers because NDA, but there have been obviously I've only been there 3 months, but there have been like a handful of times I've seen something that's actually malicious. I've seen like a DDoS attack. I've seen a lot of phishing emails. Nothing giant. A lot of these things we're able to catch and remediate before it's like a big deal. Yeah. Even if it's not like a big attack, there's still some interesting things to do though. So now I'm just going to go into some common alerts. I talked about some of these before, and I'm just going to kind of quickly talk about how we might investigate these and what we might look for. So the first one that is by far the most common is multiple failed logons followed by success. So that's basically we think they might be trying to brute force. There were a number of logins that failed or authentications from something like Kerberos that failed, followed by a successful one. So generally, we check what IP addresses were involved. Are they trusted? Are they internal? We look at how many events there are and why the failures occur. Like for example, some companies just don't want anyone logging in at night. So if you see an alert for someone logging in at night, then that might just be that their login was blocked by the system. It's not that they got the password wrong or anything, but we can also see if they get the password wrong. So if I see a thing where like in the last hour someone tried 500 times with the wrong password, then I'd be like, yeah, that's a probably a brute force attack. They should look into this. Yeah, those are by far the most common. I like to joke that because on Mondays there are the most of them. I like to joke that people forget their passwords over the weekend, and then as they go through the week, they remember it a little more, and then forget it on the weekend. It's like a cycle. Because we see so many of these on Mondays. The next one is account guessing, either like a local account or a Linux account. So they're pretty similar to the ones before, but basically they're getting the usernames wrong. Basically, a single source IP or device is trying and trying and trying a bunch of different usernames. It's funny because we can see the usernames they try, and sometimes they are like really dumb. Like sometimes it's stuff like admin or sysadmin or like that. That's just like an educated guess almost. But other times we just see someone guessing Minecraft, Fortnite, or something like that. Like I've legitimately seen that. So for those, we basically just check. We look at the whatever the source was. So if it's an IP address or a device, and we see did they ever log on successfully, and or were there any would be considered failed logins where they got the username right, because that could mean that they were trying to figure out usernames and then they found one, which could be bad. Next one is malicious domain request, which is basically they've detected an outbound connection from their network, some kind of website or domain that they consider malicious. So a lot of times these are honestly blocked. The security systems in place block a lot of these. So a lot of time it's just checking if it's blocked. But if it's not blocked, we check like the links and the hashes and stuff like that to see if it's actually a malicious website or if other people have reported it as a malicious website. But a lot of times if they're blocked, if they're not blocked, they're escalated. If they're blocked, they're closed. Because obviously if it's blocked, who cares? It was blocked. And then there's a multiple geolocations, which we also see quite a few of, which is basically they have logged in on an IP address that is not in the network. These are one of the ones that the bot can actually do. So we only have to do a few of these usually. Sometimes it's just that the SIEM itself has a little trouble figuring out where an IP address is. So a lot of the time we use a tool like IP info to see what the geolocation is and if it's a VPN. We also look at past tickets a lot for these, because if we got one yesterday saying, yeah, this guy's in France on vacation, and this one's also in France, then usually we can assume based on the region that it's the same thing, especially if it's the same IP address. Also, sometimes it's just they've outsourced work. So there have been a few where it's in India, and then it's just that they've outsourced some work to India. So it's like, oh, they're not in Canada, they're not in our office, but they're just working for them somewhere else. The next one that we see a lot is phishing, as you can probably imagine from all the stories in the news about phishing attacks. The interesting thing about investigating these is, depending on the customer, we can't always see what was written in the email. What was the subject? What was the file attached? So we can't always tell based on just, okay, that sounds like a phishing email, because obviously if it's a false positive, then they might just show us their bank statements or something like that, or a business transaction that they don't want us to see. So for the ones that we can't see for the ones where we cannot see the email, we look at sender domain. So if it's sent from Gmail, we usually escalate right away just to check, because it could be just them getting an email from someone on Gmail, but it also could be something fake, like in the news story I talked about earlier. We also check IP addresses to see if they are reported as previously malicious for phishing. In those ones, we can usually see whatever link is in the email. So if they have a link there they want you to send to, and we can check that to see if it's malicious. We also see the subject line. So sometimes that's like a little obvious that it's either a scam or phish. And usually just if there's any doubt with those, we escalate them, just because it can be the start of another attack or just something bad. Data exfiltration, that one's not quite as common, but we do see it sometimes. Basically, the rule triggers when data is seen leaving the network in like a large amount. So those ones we aren't able to see what's actually in the packets and what's being sent, but we can see how much is being sent. So if we see a few gigabytes being sent away to a suspicious IP address, then we're going to escalate that right away. But if I see like a megabyte or two or less, then I'm like, it's usually not a big deal. Sometimes we can see the application that's using it, and sometimes there are false positives with something like Google Meets or Microsoft Teams, where it is sending out data, but it's sending it out because it's a video call and it needs to send out a stream to have a connection. Yeah. And then group and firewall changes. These ones are grouped together because they're pretty similar. So basically, something about either user accounts or the firewall has been changed by someone. So this is where we check the users to see if they are actually authorized to do this. So are they on their admin list? Have they been seen making these changes in the past? Are they actually allowed to do this? Sometimes it's just that our admin lists haven't been updated. There's a new admin or something like that. So we escalate those. Some companies get us to escalate all of their firewall changes because they really, really, really want to see everything that's happening. They want to make sure it's authorized. We also see a lot of malware. For these ones, you check like stuff like hashes. Sometimes we use Sentinel-1, where you can actually like kill or quarantine a process that might be malicious, but obviously we check it first. We always check the process name and the hash, as well as past logs, because sometimes there's false positives. I saw like for example, I saw one recently where it was something that was interacting with Windows system files. So the alert was like, this could be bad. Like it could be doing a big attack with something like credentials. But really, it was just a regular process that happened to interact with the Windows files. Yeah, I'm just gonna go over my average day a little bit. So I get in, I check my previously escalated tickets, because a lot of times after I leave in the day, the customer replies and emails saying, "Hey, yeah, you closed this ticket," or "Yeah, we investigated and we remediated the threat." So you can close the ticket, or just continue the conversation with them. Then when I get at work, I claim tickets for the queue. It depends on the person. I usually try to have like 5 or 6 claimed at a time, just so I have some stuff to work through and I can kind of prioritize. Really, like you can take as many as you want as long as you're not going to breach the SLAs. For most customers, the SLAs aren't like a giant deal. They're more just an indicator of like how we're doing. So obviously we don't want to break it, but like if it's a super busy day and it needs to be, then sometimes it's fine. But like if you're just slacking, then and you're not doing any tickets, and then all your SLAs break, then that's the problem. We also do some stand-up meetings twice a week, where we basically meet as the SOC team and we on a call, and we talk about any updates, new hires, new tickets and updates like that. And sometimes the management kind of talks about tickets that maybe aren't being done right or could be done better, and kind of goes through some examples on how you would do this ticket, just to make sure everyone's on the same page with these kind of things. Another thing that I actually just did this week was a customer request. So that's basically where the customer sends in a ticket saying, hey, I need some help with something. A lot of the time it's they need some information. So the one I did was someone wanted some information on certain log sources and how many events there were in a certain time frame. So for example, this person wanted to know how many events and what types of events and like the distribution. So how many of this type of event were from this log source from 9 to 3 on Monday. So they could look at it and figure out what they're getting the most of. So for that, I basically just had to do some searches, export it to a Excel file, and I had to organize it and basically turn it into some charts. I'm not very good at Excel, so it took a little bit of time, but it was fine. These customer requests don't usually have like a time frame to do it on. In fact, you're kind of told not to give them a time frame just in case something happens or there's some issue. But yeah, this one took me a few days to do just because I never used Excel before that much or in this way. So I needed a lot of help with that, but it all turned out fine. The other thing, I haven't done this yet, but it's generally a duty of an analyst, is reports. So we create monthly reports for our clients and on a variety of different statistics and things like that about the alerts that are coming in, and we send it to them at the end of every month. So that involves a lot of log searches, a lot of big searches. Like sometimes they're running and like it makes the whole thing slow because people are doing searches for the past month, all the tickets for certain things, and then you like the customer request, you put it into Excel, you make some charts to show the information. But with this one, you also do a little bit of writing about kind of patterns you might see, what this could mean, and maybe what they can do about it. And then at the end of the day, I respond to any tickets that were replied to during the day. And the way it works with tickets is if you don't hear back from them, you send another comment saying like basically, hey, is there any update on this ticket? Just to kind of like poke them and say, hey, kind of waiting. And yeah, and so the way we do it is you send 2, so one every day for 2 days, and then the third one you basically say, hey, are there any updates? And this ticket is going to be closed if you don't respond by tomorrow. And then on what would be the 4th day after escalating it, you close it, and you can mark it as no reply, and then the customer can actually see that there was no reply. That they didn't reply. So sometimes they get back to you right after you mark it as no reply, but a lot of the time that's just more a statistic on them than us. And then at the end, we fill out a little form for shift turnover, which is basically just a little bit of you just write a little thing for each like high priority request. There's a certain client where you write how many requests we did for them, how many tickets are in the queue when you leave, do you have any customer requests ongoing or any reports ongoing, and if there are any big updates. Just so if the next shift gets a call, let's say, or something happens, they can check the turnover document to see if there's anything there that could like indicate something's happening. I'm just going to talk about the skill set quick of an analyst and stuff that you might want to focus on learning for the position. What was kind of cool is, so I actually checked with my boss when I was doing this talk because I wanted to make sure I'm not saying anything I'm not supposed to or going to get in any trouble for it. And I was gonna write about this skill set, but I was kind of in the middle of it. And he actually opened up a document that we weren't able to see yet because it was work in progress that he was working on with some of the senior analysts. And it was basically a rubric that said where you should be at in certain areas of competency, like where your knowledge should be and where your skill should be. And he just showed me it, like where you should be as a like co-op, like X amount of time in, or as a tier 1 or a tier 2 or a tier 3. So a lot of this actually came from that. So I thought that was kind of cool. I was worried he'd say, "Oh no, you can't talk about this," but then he actually helped me, so that was kind of cool. So first off, knowledge of different attacks and their causes. It's really hard to investigate if you don't know what you're looking for. If you're just looking at some, you kind of gotta be able to figure out or learn based on some types of alerts and patterns what might be happening. So if I see a bunch of, for example, if I see a bunch of traffic being sent all at once and a bunch of tickets, that could be a DDoS. But if I don't know what a DDoS is or what it looks like, I might just be like, okay, there's a bunch of traffic coming in. Attention to detail and ability to learn quickly. So there's a lot of different fields in the tickets and in the alerts. So you kind of need to know and be able to see what you need to see and figure out what you need to know to get the full picture of what happened. And also, there are a lot of types of tickets, and there's basically new ones coming out all the time that might have been handled once. So you need to be able to figure it out and learn quickly. Honestly, it's fine to just ask. Odds are someone's done it already. Most of the time, if you look, you can see someone did this tick in the past. And you can just message them and say, "Hey, I saw you did this tick in the past. Can you like kind of tell me how you did it, or kind of give me a rundown?" Knowledge of logs and how to read them. A lot of these logs have a payload attached to them. So the scene kind of parses the payload and gets some important information. But sometimes you can't always see everything from just that alert. So you have to be able to read the payload, which a lot of the time is a big block of text all scrunched together. And you have to figure out what you need to know from there. Investigative skills, because when you're investigating something, I was actually at one of the get-togethers recently, and I was talking to one of the tier 3s. He said one of the differences between the people who like just do the job and are like good at the job is their investigation. Like, are they asking why? Are they trying to figure out why these alerts are actually triggering, or are they just kind of going through the motions? So you want to be able to try to make a picture of it, of what's going on based on the past logs and what's happening in the alert. So you need a knowledge of the customers and their systems, what might be happening on a certain system based on certain alerts, what their specific alerts are, what kind of security measures they have in place, and things like that. So if I know that client A gets a load of these types of tickets, and a lot of them might be false positive, then I might look for things that might show that they're false positive. Or if I know that this customer gets hit by this a lot, it might set off alarm bells when I see something. You also need knowledge of the SIEM system and how to investigate with it. So another thing that I've been told kind of separates different like people who are just doing it versus people who are good at it is how they investigate and how they do searches. So you can a lot of the time do an easy search, just group by the event name and by a certain source IP, and you can see a bunch of stuff. But if you really want to get a good picture, a lot of the time you need to do multiple searches, filter by a few things, just to get different ideas on what's happening and like if it will be malicious or not. So that'll involve adding more things to your search, filtering by certain things, looking at different times. A lot of time what's useful is the theme, like when you have a bunch of events in a search, it'll give you a little graph. So you can look at that to see the timeline of events. So you can see, okay, there were 100 events between 8 and 9. And then there were 2 for the next 3 hours. So you might be like, okay, what was happening with those 100 alerts. Were they all failed logins? That might be suspicious. Yeah, so it's useful to have a visual representation. Also, knowledge of the EDR and security solutions that may be in place. So yeah, just you need to know the client and what kind of security they have. It's not always like laid out, like we don't know, okay, these people have this, this, and this. You kind of just learn it by doing tickets. It was funny. I did one recently. It was one of those malicious domain requests. And you know how I said most of the time it just says it's blocked? Well, this one didn't say it was blocked. It said like the action taken against it was null. So I was like, oh no, what's going on? But then I realized that this was a French office, and the event it didn't parse the payload to realize that it was blocked in the payload. And so if you looked at the payload, it said this event is blocked. This event was blocked in French. It just didn't read it properly. So when I was early on in my co-op, I actually escalated one of those, and they said it was blocked. I'm like, okay, I'll check for that next time. It's funny, just those little things that it might miss that you have to kind of know about. And yeah, you have to know their security, what's available, because some clients have more things you can check than others, than just their logs. So you need to know that you can check it to be able to check it. And lastly, like I said before, the ability to use Excel helps because there's a lot of reports, a lot of customer requests that you're going to need to reply to and send a report in, and that report is in Excel. So yeah, that's my talk. Hope you all enjoyed it. If you have any questions, feel free to ask. I'm happy to answer anything. If you want to message me after, you can. Feel free to unmute your mic and ask a question if you want to, or put it in stream questions. I'm happy to answer.
Thank you, Jackson. Do you have like a LinkedIn that people
Oh
might
yeah,
be
I
able
can
to
post
do
that.
that?
I can post that. Let me just stop streaming. Let me just get that. Yeah, I'll post that, and feel free to connect with me. Christian, hope everyone enjoyed. Oh yeah, saying so from what I've heard, the programming is more in like the tier 3 level where people are working on like automation. Generally in the day-to-day there isn't that much programming. It's more like, yeah, we use the software, and sometimes you might be able to write a script to help you out with something, especially with like a report that might be able to automate it a little bit, but no, I haven't used any in my experience so far. Maybe when I'm a little more experienced, I will. And yeah, here's my LinkedIn. Yeah, and it's as a co-op position goes, like it's a very common position that you might get. And yeah, it can lead into a lot of different jobs. I've seen people go from it into forensics, to incident response, into like a variety of things, because it gives you a little bit of knowledge about a lot of things. And of course, there's a lot of room for advancement within a SOC itself, like tier 2, tier 3, management, stuff like that. Yeah, and if anyone ever has any questions for co-op, if you're going for a similar position, feel free to message me. Yeah, hope you guys enjoyed. The scariest ticket or highest stress? Yeah, I can't give client names. I'm not allowed to. Yeah, let me think. Scariest ticket. Good question. Me and the other co-ops early on, we noticed a DDoS because they were like, it was like, because what we do is with the queue, it doesn't reload automatically. So we use like a little like Google extension, like an auto reloader. So every 10 seconds, it'll reload your screen to show you more. And we just keep seeing these one ticket, and it was like every time we reload, like 25 more showed up, and it was getting to multiple pages of just these tickets. And so we actually put it in our chat, like, hey, there's a lot of these, like, something going wrong? And the tier 2 lead replies, DDoS, and eye roll emoji. Other than that, I can't really think of much. Some of the malware ones are just a little bit stressful, just because, like, if you don't want to mess up those, that feels a little scary. Other than that, there's nothing coming to mind that's super scary right now. And saying, yeah, forgot to say it earlier, but there's 3 co-ops working right now. And then there was someone who was getting onboarded at the same time we were and doing the training with us. And yeah, so a lot of the time at the start we were working together. Now it's kind of like we're on the same shifts together, but it's like we just kind of collaborate a little bit if we need help, but it's kind of separate now. Yeah, Gem, higher tier SOC roles in your sights for the future, or are you trying to break out into different branch of InfoSec? Yeah, I am not 100% sure yet. I'm 3 months in. One thing I like about ISA is it feels like there's a lot of ability to move. One of the people who started as a tier 1 same time I did was a administrative assistant before that, like a total non-technical role. She did her security plus, and the company helped her move over to the SOC basically, and got her all set up there. So I do think like I could stay at I really like the company so far, so I could stay there and potentially change roles. They've just started a defer team that seems really interesting. That's something I've thought about, but also I think the SOC is cool, and it could be cool to be a tier 2 or a tier 3 eventually, or even in management. So to sum that all up, I am not sure. I'll get back to you. Yeah. If anyone else has any questions, feel free to ask. Yeah, so what the interview involved. So I actually did 2 interviews for similar SOC roles, and both of them were very different. So the one I had for ISA, it was 1 interview, which was nice, not very stressful. It was with the SOC manager and the tier 1 lead. It was pretty quick. It wasn't really super technical in the way like there were a few like do you have experience with using any SIEMs before? That was a big one. But a lot of the other questions just seem to check for like to see if you're passionate about security, because obviously it was a co-op role. Like they're not going to say like, oh, do you have a bunch of experience in the industry already? It's like, do you have a little bit of experience? Have you done research? Are you interested in security? Like, or is it proved? Like, do you follow other things? I talked about ISSessions a lot. That was a good thing. Sorry, I'm just trying to think back. It's a while ago now. The questions were more like, at least for me, they were more like, what kind of like what kind of experience do you have with this kind of thing? So like what kind of experience do you have with troubleshooting or problem solving or juggling a lot of things at once? So it was a lot more soft questions, like soft skill questions, I thought. And my other one was it was two interviews. One was like an HR interview, and then the other one they actually showed me a diagram of a of like a system, and they said, okay, where would you put an IDS or an IPS? So that one needed a little bit more prep, but they kind of let you know what you would need to expect beforehand, what you'd have to do, like a little bit. Does it generally prepare us well for these positions? I think so. There was, we didn't really like talk about SOCs specifically, I found, but in like the networking courses, we talked about IDS and IPS systems, so I can talk a little bit about that. We talked about Splunk with which prof was it? My mind is blanking, but Jem will know. My mind is soup right now. But yeah, I do think, and also the FODI, yes, FODI, yeah. The networking classes helped. I found forensics helped. Not necessarily using the same tools, but kind of the idea of investigating and looking at what might be a sign of something bad happening. C3X definitely helped. Also, because they asked had you used a SIEM before, and I was like, yes, I participated in C3X. We used Splunk with the Elk stack and a bunch of stuff with that. And then I also talked about, because with ISSessions, if any of you guys did the KPMG workshop, which was basically an incident response where we used, I don't remember what we used there. Christian would, I don't remember what tech we used there. It was a great one. Yeah, Jem, it was awesome. And I helped test it. So I was able to say, it was actually a week before my interview that I did that. So I was like, yeah, I went in for 3 hours and helped test a investigation scenario. Yeah, with Splunk. With a few other things, yes. So I was actually able to say like, yep, when have you used a SIEM before? Yes, last week. So yeah, it's probably good to get a little bit of experience with that. Maybe look into a bunch of courses, a bunch of videos and stuff about different SIEMs. But I don't think it's a requirement. It's more of a nice to have, I think. Yeah, no problem, Sam. My messages are always open if anyone has any questions. Also LinkedIn too, if anyone wants to message me there. And yeah, I guess we can finish there for tonight, I guess. Thanks everyone for coming out.
Yeah, it seems like a good place to wrap things up. Thank you, Jackson. Really interesting talk. And thank you everybody for coming out. Tentatively, our next session is scheduled for, I believe, the 25th of August, our last summer session. Hopefully, we'll see you guys there. Otherwise, have a good night.